An ephemeris is a table which documents the path of astronomical objects. Moving through the air, these particles can be seen as a kind of ephemeris. They map the atmosphere's movement, where it is volatile and where it is stable, where it is cool and where it is hot. Where they gather, they create visible changes in the light. So the movement of these particles is indicative of something much vaster, the movement and changes of the atmosphere.
The sun is rising here at Ashton Court. Welcome one and all to the International Bristol Balloon Festival. And it's the 20th year of the mega balloon taking off. And what a beautiful day for it. You can really tell it's time for this year's dispersal.
The balloon is tethered to the ground. The tether is also a pipe. It is 20 kilometres long. Its base is at an old quarry on the outskirts of Bristol. The tether stretches from the deepest part of the atmosphere, the Earth's surface, and through the dense troposphere. It ends at the balloon, on the boundary of the stratosphere. Aerosols are pumped up to the tether to be dispersed at the height of the balloon. The aerosols are particles which reflect the sun's radiation, creating a cooling effect. These particles gradually drift towards the bottom of the atmosphere. Blue light waves are scattered as they attempt to make their way through this particle density. The sky appears paler and pink. There are 4 balloon sites around the world. In total, they pump 10 million tons of aerosols into the stratosphere over 200 days per year. They remain in the atmosphere longer at this height because the air is thinner. Yet for a long-lasting effect, this kind of injection has to happen regularly. As the aerosols gradually drop out of the atmosphere, in the same way that a volcano eruption clouds the sky relatively briefly, the dimming will only last if the dispersal continues. This artificial manipulation of the atmosphere has spatial consequences in the way it affects phenomena such as light and air. The manipulation itself is facilitated by the vast infrastructure of these balloons. The balloon has been a symbol of Bristol for decades, and now the flight of the geoengineering balloon has become a spectacle which thousands of people come to the city to see for themselves. Hanging under the balloon are the propane burners for heating the air inside the balloon when the solar heat is not enough. There is a living pod for the geoengineer, and there is a dispersal unit. This is where the aerosols are transformed from a concentrated high-pressure liquid into a low-pressure cloud of particles and dispersed into the atmosphere. The geoengineering balloon is 315 metres in diameter. It is a hybrid balloon which lifts itself by harnessing aerosolar and helium technology. The interior sphere is helium, whilst the ribbed outer balloon is trapped warm air. The interior balloon also acts as a ballonette. This is a way of maintaining the same size and shape of the entire balloon, as it experiences various different altitudes and pressure changes by gradually deflating the interior balloon as the entire balloon rises. The balloon initially ascends through the troposphere. Most weather phenomena occur in this layer of the atmosphere. At 400 meters altitude, the conditions become ideal for harnessing wind energy as the wind speeds are high and constant. Blades spin around the tether to generate electricity. These blades also help to lift the tether. As the balloon climbs through the atmosphere, the sky becomes blue once more. Temperature gradually decreases with height throughout the troposphere. Between 10 and 15 kilometers, carbon dioxide freezes easily, and when the gas hits the blades, it turns to shards of ice and is collected and sent back down the pipe for sequestration in the depths of the ocean. The balloon stops climbing at an altitude of 20 kilometers. This is the tropopause, the boundary between the troposphere and the stratosphere, between sky and space, between blue and black. Temperatures in the lower stratosphere are around minus 60 degrees. Unlike the troposphere, the temperature gradually rises through the stratosphere, meaning little convection takes place. This means that the conditions are relatively stable, and the balloon can almost be parked in its position. The air becomes dry, devoid of water vapour. Its density here is very low, and the geoengineer must stay in his pressurised pod or wear their high-altitude suit if exiting the pod. The particles are dispersed. They begin to move through the atmosphere, taking on the shape of forces which may affect them. They reflect the light of the sun. The balloon and its geoengineer remain at this height, slowly rotating for 200 days per year, every year. This has a cooling effect.